All right, we're switching gears here a little bit. So if you've been doing these in order, you've been studying sign charts and the signs of function at increasing and decreasing intervals and all that. Here, we're interested in something you're very, very familiar with. So this is asking you for the average rate of change of this function on the interval -8 to 2. And this is something you've been studying very hard since like 8th grade probably. Average rate of change. Rate of change in math usually just means slope. So average rate of change is another way of saying average slope. You may have heard me say before that slope is a big, big component of our first semester of calculus together. So we're getting a jump on that here. So let's mark out our interval to start. So x equals -8 and then x equals 2. So we have these 2 points. Let's imagine this graph is something like a little more concrete. So let's say x is time and then y is your speed. So let's say, I don't know, you're driving to school. Let's say the morning bell rings at x equals 0, time equals 0, right? So these negative times are before school, and then these positive times are after the bell rings, so you're late. And let's say you're driving to school. Your speed is positive, means you're going towards school, and then your friend calls you to pick you up, so your speed being negative means you're driving away from school for a little bit to go get your friend. And then you start driving back towards school, and you realize you're about to be late, so you're speeding up, speeding up. And then eventually you get there, right? And then you slow way down. And then I guess you leave again 4 minutes later or something like that. So that story didn't make a whole lot of sense given the shape of the graph, but that's a context where this would be useful. So what we'd find from -8 to 2 would then be your average change in speed. So are you speeding up or slowing down, and by how much over that interval? I'm going to draw a line in here, just a little dotted line, and that's going to help you figure this out, because average rate of change is just the slope of this line. So I can do this a couple of ways. Here I'm just going to do rise over run. Okay, so it looks like I go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I go up 5 to the right 10. My slope is positive. So my average rate of change, Iraq average rate of change, is just 5 over 10, which is just 1/2. So this is really just slopes through the 2 points. The only way you can get this wrong if you know how to do slope, which I'm praying to God that you do, is by picking the wrong point. So just make sure you're working precisely. So there's a couple different ways you can see this. Another way is a table. You've done slope here before, right? Remember, we're not just finding the slope of this function because it now changes over the course of the graph, right? We're finding the average rate of change over 2 points. So if I have to use 3 and 7 here, because if I use 2 and 4, I'd get a different answer. But the math looks exactly like you're used to. So 1215 minus 15 over 7 minus 3. So this is sometimes called the difference quotient. Really, it's the slope formula. It's often written, now that we're later in your math career, something like this: f of a minus f of b over a minus b. So this is the same as just like y1 minus y2, x1 minus x2. It's the same math you've always been doing. What we get here is, of course, 1200 over 4, which is 300. So that's my average rate of change from 3 to 7. And you can check, right, if I plugged in like 4 and 2, like these 2 points, my slope would now be different. So we're talking about the slope now of functions that have different slopes in different spots. Okay, here, this looks a little different, but this is actually the same thing. So here we're given the function instead of a graph or a table, and we're finding the average rate of change over the interval. So we're still going to use that difference quotient formula, or really the slope formula, right? So it's f of a minus f of b over a minus b. So what that would look like in this case, right, is f of -10, the order doesn't matter as long as you're consistent, minus f of -1, all over -10 minus -1. Okay, so because we have a function here, we can just plug in our values, right? So this would be like -10 squared minus 7 times negative 10 plus 18 minus, and everything gets parentheses here, negative 1 squared. So if you get these wrong, by the way, just make sure you type them into your calculator correctly. Negative 7 times negative 1 plus 18. All over negative 10 minus negative 1. Okay, so that's a bunch of math that you can do. I just plugged it in twice. I'm going to show you an easy way to do it on your calculator. This is the same as the last lesson. We're going to use the grapher and the calc value function. So I've typed my whole thing in, and remember I need f of 10 and f of negative 1. So I'm going to do second calc value, and then type in, negative 10 and negative 1, right? Type in negative 10, and I get negative 12 was my first one. And then I'm going to do negative 1, and I get 24. So negative 12 minus 24. And on the bottom I have negative 10 minus a negative 1. Well, that's negative 9, right? And then we have negative 36 over negative 9. And it works out to a nice round number. That gives me a positive 4. So that is my average rate of change. So the math, no matter how I give these to you, either as a function or as a table or as a graph, is always just the slope formula. That's something you already know how to do.